Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12th. We are doing chapter number 5 of the class 12 from NCERT book, that is nothing but our continuity and differentiability, as you can see in your title also. And we have completed its introduction video. We have completed each and every questions of exercise 5.1. Now, if you want to if you are new to this channel and you are watching this video first time, you have any doubt in the previous exercise, or you want to see its introduction video, like it's a quick recap for you guys, so you can visit to my previous videos so that you can easily find in the channel. Now in this video we're gonna start exercise 5.2 of this exercise of this chapter 5, as you can see in the title. Now let's in this video we will do question number 1, 2 and 3. Okay, so this in this platform we gonna do maths which in a very simple way so that you can understand it clearly. Okay, so let's move ahead to this video. So in this video we're gonna do question number 1, start with question number 1 of exercise 5.1. Okay, what we have to do in this question? Differentiate the function with respect to x. Okay, so what we have to do, we have to differentiate our function with respect to x. As you can see, this is our function for first question. So let's begin. Okay, as you can see here, this function is a sin x, and it is a sin x of x square plus y square. As you can see, this can be written as a composition of two functions. What are the two functions? So take your v of t as sin t and your u of x is x square plus 5. Now you can say, suppose if I give this function to the name f of x, so you can see your f of x will be is composition of these two functions. If I try to write it to you explicitly, I'm explaining the first question very in detail how you should do that. So your v composition u of x, so this will be v of u of x. How we write our composition like this? So u of x is nothing but x square plus 5, and v of x square plus 5 will be nothing but here your t value. Here your t value is nothing but your u of x, which is nothing but x square plus 5. Remember this, we will use this ahead. Okay, so take it as 1 if we want to use somewhere else. So take it, name this as 1. So your v of x square plus 5, as your t here is x square plus 5, so v of t is nothing but sin t. So this will become sine of x square plus 5. So which is nothing but our f of x function. So what we did here, we just write our function f of x in a composition of two functions. And now let's differentiate this function. We know that if we have to differentiate the composition of two functions, in that case we have to use our chain rule. Okay, so let's do it. Now what we have to do, we have to differentiate f, that is, we obviously know that it is denoted by df by dx. So we're gonna use chain rule here. So what we'll do, your first function is v, right, the outer function. So we will differentiate your v with respect to t, because our v function is in terms of t. Now then we will differentiate our t with respect to x. What is t here? T is this, right? We will use this here. So now what we have to find? We have to find dv by dt and dt by dx. That means we have to differentiate v with respect to t. That is nothing but differentiating sin t with respect to dt. And we know that this is a standard differentiation of our sine function. This is a very standard differentiation. I have tell this in our introduction video also. Or if you don't see or don't want to watch that introduction video, you can see in your textbook, that is some standard differentiations are given in your, I think, table 5.3. In your table 5.3 you can see that some standard differentiations are given, as I will list that differentiation which we'll use here. I will list those. Okay, so here sin x differentiation is nothing but cos, that it will become cos t. That is what I am trying to say. Derivative of, I am writing like a sin t, uh, derivative of sin theta with respect to that variable theta which is nothing but our cos theta. I have used this. This is a standard differentiation. I just use this. Okay. Now, next what we want is dt by dx. That is dt by dx. So our t here is nothing but our u of x, and our u of x is nothing but x square plus phi. So this will be derivative of x square plus phi with respect to x. And now we will use the algebra of differentiation. We know that this is like linear in nature. If we have to find its differentiation, find their differentiation separately. That means dx square by dx plus d of phi by dx. And we know that for any x raised to n, its differentiation is n into x raised to n minus 1. That is, okay, what I will write here. So what we are using is, because differentiation of x raised to n with respect to x is nothing but n raised to x raised to n minus 1, where n is some integer. So this will be nothing but 2x. Okay, and we know that differentiation of some constant function with respect to the our variable is nothing but 0. As you can see, phi is our constant function. So differentiation of phi with respect to x will be 0. So this is 2x plus 0. So this differentiation is nothing but normally 2x. Now put these values here. So our dv by dx is nothing but cos t. So as we want to find, like I will write it like this we have find. I am just putting the things in our required part. So this will be cos t into 2x. Now put the value of t. So if I put the value of t, so our differentiation will be cos value of t is nothing but x square plus phi multi 2x. So this is our differentiation of the function, right? If I like write it here completely, so our differentiation is nothing but derivative of f with respect to x. This comes out to is nothing but 2x multi cos of x square plus phi. This is our differentiation of the function, right? We are done with our first question. And as you can see here, we are just finding the differentiation by using chain rule. You can easily find this type of question, like the differentiation is like next topic to the continuity, right? Continuous function. We have first studied the continuous function. Now we are moving ahead, one step ahead. That is nothing but differentiation. And differentiation, you can easily find at least one question of about like finding the differentiability. It is not at a particular point, but you can have two type of questions. So in differentiability, you can only have two type of questions. That is finding the differentiation of a function, or otherwise find the differentiation of the function at particular point. Now here, this is the first case when you have to find the differentiation of a function. You can easily get at least one question in your board. As you can see in the previous this our 2025 2025 board or 2026 board, you have always have at least one question of differentiability. So please, this is my request to you. Do at least good practice of a differentiation question or like differentiating a function, because it's a very important part for you, especially where you have to use your chain rule, because this is the crucial part where how you should guys think, how you should like find the composition of the function, because it's not like you easily see what composition you can make. It's like it's come with your practice. Always do the questions in mathematics. Whenever you do lot of practice, it will help you a lot, because your practice will be make you perfect for solving the questions in very less time. Okay, so next move to the next question, that is in case it's question number 2. Here also we have to find the differentiation of the function. Now as you can see, I will give it to you as a homework, this question, because this is same as the previous one. Here you have again you have to use the chain rule, but if you have like, if you are beginners, you are having a doubt what should be your composition function, I am giving you a composition function. You are to just use your chain rule. So as always, take the outer function as v, take it with the variable t. So outer function v of t. So as you can see, outer function is cos function. So our v of t is nothing but cos t. Now always take your inner function as u and with the variable x. So your inner function is nothing but sin x, as you can see. So your ux is nothing but sin x. So now you can easily see V composition U of X is nothing but your given function. If I name this function by f of X, so this is f of X. You can verify it by yourself. I am giving you also to verify it first, then use it in your equations. Now what you have to find, what we have to find, we have to find our df by dx. This is your homework. How can you do that? I'm just giving you hint. Your hint is, sorry, your hint is your df by dx is nothing but, by you use your chain rule, that is nothing but dv by dt, because v is in terms of t, right? And as your u of x, it is sin x. As you can see, your u of x is work as t for v. So from here, what you get always, you can, whenever you are like proceeding ahead, you can easily find the way where you should go. Okay. So as for example, I want, if I like simplify it, you can easily see that your u of x is nothing but work as t for v. So from here, your t is nothing but u of x. So this is dv by dt multi dt by tx, like differentiating with with respect to t, and then multiply with differentiation of t with respect to x. This is your hint. Okay, just apply these things, you can easily get your answer. Okay, if I gave you answer, no, I am not giving you answer because I have totally gave you the hint. You can see your answers, where like it's very easy to find answers because it's in the last of your book also. Okay, now let's move to the next question. Okay, this is also same question, but may I help you in this question? Okay. So here also, let's start with the same rule. What I have told you, take this function as f of x. But I always take your outer function as v. So your v of t is nothing but sine t. Take your inner function as u. So u of x is nothing but ax plus b. Now your f of x is nothing but, okay, I will write my f because it become too complicated when I write all the things together. So I will write my, from here, your, as you can see, your f of x is nothing but v composition u of x. So from here, your v composition v of u of x. So as you can see, your t is nothing but your u of x. So now what we have to find? We have to find the differentiation of the function f with respect to x. So our df by dx will be nothing but, you have to differentiate your outer function with respect to t. Now somehow we want the differentiation with respect to x. So what you will do? You will differentiate your t with respect to x. Okay, just put the values, put the differentiation. So what you have to differentiate? Differentiate sine t with respect to dt, multi differentiating your t, or your t is nothing but u of x, or your u of x is nothing but ax plus b. So this is ax plus b divided, no, not divided, sorry, ax plus b, differentiate with it with respect to x. Now I have already told you, you have, this is a standard differentiation. Differentiation of sine t is nothing but cos t, and differentiation of polynomials is a very good, you have practice in like smart in that also. But if I like tell you, you know that differentiation of x, I already told you, differentiation of x raised to n, its derivative, some, if I take any some scalar, you can take your scalar out, right? That's not making problem here. So differentiation of x raised to n is nothing but, its derivative is also represented by dash. This means the differentiation of x raised to n with respect to x. So this is nothing but n times of x raised to n minus 1. So from here, your ax have the differentiation. Take your scalar out. Your x has a differentiation of 1 only. Now differentiation of b, as you can see, your b is constant, so its differentiation will be 0. So this will be, comes out to be cos t multi a. So as you just put the value of t, that your cos t is nothing but ax plus b. Okay, so this is not, this is your df by dx. We have find the differentiation of this also. Okay, so we are done with our 3 questions which we want to do in this video. So that's all for the today's video. Keep practicing this differentiation questions. Most probability of questions that will come in your exams, or like you should know that questions with very practices. You're differentiating the function which use chain rules. try to do that type of questions, because it will be very helpful for you how to think, to how to like make your compositions, how what you should take it as a first. I have to give you the trick also. Always take the outer function as outer always take the outer function as v, and then inner function as u. If there are three, then do in like accordingly in that order also. So that's all for today's video. I hope you guys like this video, and please do each and every questions by yourself. Please do your homework question also. I am lefting the homework question because these are the same questions. I don't want to waste your time if you have the same questions again and again. I have to like, my motto is to teach you variety of questions, not the quantity of questions. That's why I am like using the variety, not using the quantity. So keep practicing, keep learning. Let's meet in the next video, and please like, share, and subscribe.